Hello, dear aspirants. This is Dr. Sourav sir's class. We are trying to now get a new proof from of what we know this thing from our very childhood that our AM is greater than equals to GM is greater than equals to AHM. That is, my arithmetic mean is greater than equals to geometric mean, and it's also greater than equals to our harmonic mean. So So let us talk about this thing as our let A1, A2 and our AN are what? So our AIs are greater than 0. That means our AIs are positive and positive real numbers also. Yeah. And our I belongs to 1, 2. Then this thing holds. That means our AM greater than equals to GM greater than equals to HM holds here for as what is our AM now? Our AM is the sum of from our A1, A2 up to AN divided by n. That is my arithmetic mean. And now what is my geometric mean? We all know that the nth root of A1, A2 and the product up to our AN. Yeah. So this is my geometric mean. And now what is my harmonic mean? So that is n by 1 by my 1 by A1 plus 1 by A2 dot 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 our 1 by AN. That is n. Okay. So this thing we'll all know from our childhood. So we are going to get a new proof for this thing. So now we can do that the theorem is true for our n equals to 1. This is obvious, but again I am telling that the when our n is equals to 1 we will get only one term, so the term is my a1. So the arithmetic mean will remain same and the geometric mean will be the 1th root of a1, so that will also be 1. That is equal, no? And the harmonic mean is what? 1 by 1 by a, so that will also be our a1, so this is also a1. So our am is g equals to gm equals to hm holds here. So for n equal to 1, the trivial case, so this holds. So now suppose now the theorem holds true for our n minus 1 cases. For suppose this theorem is true for our n minus 1 up to n minus 1, then that is what? That is my a1 plus a2. Yeah, upon my n minus 1, and this thing is the whole root of my n minus 1. Yeah, n minus 1 and up to our a1 a2 up to our an minus 1, then less than equal. Okay, I am writing wrong here. That will be my greater than equals to. So this is my n minus 1 by, yeah. So now let us do a magic on this. How can we do that? So we may write, we are going to check the in for our n terms. So in that case, let us take one thing, that our a1 be a and our a2 be what? That is my b1a dot 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 up to our an will be bn minus 1 into a. Now for some suitable b1, b2 and bn minus 1, they are also positives. So, so we will get the thing from our formula. So we will get a1 plus a2 and dot 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 up to we will get an by this. Now I am rewriting the formula so it will help us to put the things here. Yeah. So my a1 is what? So that will be my a plus b1 a dot 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 our up to bn minus 1 a and upon my n. So this will be what? This will be my nth root of a1, that is my b1 a dot 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 up to bn minus 1 a, and again also this 1 by a plus 1 by b1 a up to 1 by bn minus 1 into a. So the a will be common from everything, from the three things. And how could we get our a? So we can easily see from this thing our a will come outside, so my remaining part will remain here, and there is my a. So a to the power n in the nth root of n, so nth root of this, so our a will come outside. Now here will lie n and our b1 up to bn minus 1, and greater than equals to what will remain here, we will get n, and 1 by a will be the common in our denominator, so if we take it to the numerator, so it will be 1 and we will get this thing. So now our a can be cancelled out from these three things, so now we will get just only we are rewriting all the things. Yeah, that is a minor mistake. Yeah, so we will get this here upon n, and nth root of my b1 b2, that will be my bn minus 1, and n upon 1 by 1 by b minus b1 dot 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 1 by bn minus 1. So now firstly we are going to think about our only this part, so our am is greater than equals to gm. In that part we can do something, that is we can rewrite this for our n minus 1th case, so we can write it in this manner, that will be my b1 b2, as our bn's are also my positive things. Yeah, so now I want to do this. Yeah, so the just the n minus 1 will be arrive in the RHS. So now I am just adding 1 in both of the sides. Yeah, so if this so we can show that this holds true. So now it suffices to show that this thing, so our this thing will be greater than equals to n into this b1 b2 dot 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 up to bn minus 1. Then the upper, then this case, then this yellow, yeah, so this case will satisfy here. So now what can be done for this thing? For this thing we can write that let x be my n into n minus 1th root of b1 b2 dot 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 bn minus 1. So we can form a polynomial that will look like what? So the last inequality can be rewritten as our 1 minus 1 plus n minus 1 into my x to the power n, that is greater than equals to n x to the power n minus 1. So the function, so now we are considering a function which is my fx is equals to 1 plus our n minus 1 into x to the power n minus n x to the power n minus 1 has a global minimum at our x equals to 1. I am writing that our gm is has another meaning here, so I am writing my global minimum at x equals to 1. When we get our global minimum, if our fx is greater than equals to fa for all x belongs to the domain, so our at x equals to a, the point is my global minimum. So what is global minimum here? So for our f1 is equals to my 1 and n minus, that will be my n minus 1 minus n. So 1 and 1 will cancel out and n and minus n will be also cancel out, so we will get 0. So our fx is always greater than equals to 0. So as our fx is greater than equals to 0, so the inequality holds. So the inequality holds true for n. In order to prove the GMHM inequality, we use the induction hypothesis. Again we will do this thing for our GM and HM. So what we are doing here is, yeah, I want to write it with my red color. So we will get what? We will get the nth root of b1 b2 dot 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 up to our bn minus 1. Yeah, and this is my greater than equals to, which is my up to bn minus 1 to the power what? So that we are taking the n, yeah, so our n minus 1, so the power will be in the same thing as our appears here, so we will get n minus 1 by n here. Yeah, let us take it holds. So now it will be enough to prove that if our this thing is greater than equals to my what? N by the 1 by b1 to up to my 1 by bn minus 1, and the which thing is written here as this part. I am going to prove this now. So we again have to take something to do this. So let us take our let our y be my 1 by b1 plus dot 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 1 by bn minus 1. So now we have to rewrite the equation again. So by rewriting the equation, we will get my n minus 1 upon y whole to the power my n minus 1 by n. Yeah. So again it is my greater than equals to n by 1 plus y. So which taking logarithms to of both sides. So we are taking logarithm both sides. So we will get our n minus 1 by n. Okay, let me do it. So I am, yeah, so I will get this thing. I want to just avoid calculations now. You can do this by yourself. Yeah. So our n ln n is here and the 1 plus y. Yeah, am I writing written x here? So that will be my y. Okay. So now letting our gx be this thing. So our letting gx, that means gx now I want to write our gy. So that is my this n ln n minus 1 and this thing I am rewriting this also again. Yeah. And it is a routine matter to just show that our gx has a global minimum at my n minus 1. So what is global minimum? I have told you before, global minimum at n minus 1. So we will get what? So at our g of n minus 1 we will get my n minus 1. uh, I want to write it with our another color. This color is, so yeah. So our gn minus 1 will be what? That is my n minus 1 ln n minus 1 plus our n into n minus 1. So n minus 1 plus 1. So it will be my ln n minus ln n minus 1 minus ln n. So these we all are cancel out. So it will be my 0. So my gy is always greater than equals to 0. So the next part of the question is where we get this thing. So our this thing, this equality, this inequality holds true for all, and if this is true then this is also true. Yeah. So I have done. So our AM is greater than equals to GM and it's also greater than equals to HM is proved. Yeah. Thank you guys. Hope you understood. This is a very generous proof. Thank you guys.